Hello everyone, welcome back to System Design Interview Series. Today's topic is System Design Patterns and today's topic is Bulkhead. So in this particular session we'll be covering on what is Bulkhead, what is the problem context generally it is applied to, what are the different issues and considerations we should have in mind before we consider this particular pattern, and finally when to use and when not to use, and some of the possible use cases for this particular pattern. Jumping on to this pattern. So bulkhead pattern suggests separating both functionality and data, which helps in ensuring service availability. Even though there are some of the services which might would have failed, while the ones which are still alive and providing service should be able to service. So what we a problem context of a cloud-based service. A cloud-based service generally comprises of multiple different microservices, each serving out or carrying out one or different functionalities depending on the boundaries set for those microservices. And there are multiple consumers to each of the services. In case one of the services goes down, do we need the entire service or all the services to go down? Example can be, consider your service be a e-commerce website where you have a product catalog, where the catalog or the product discovery service is there, and it's due to any surge in overall traffic, it's not able to perform. Do we need to disrupt even the booking and basic any kind of a purchase someone is carrying out on that particular portal? Consider Uber. In case Uber's payment services are kind of down, should it impact even the ride hailing and ride assignment services? There are different aspects or problem context to which this particular pattern caters to. In this diagram right now, there are multiple clients and multiple services. They are interacting with the services over some level of a layer. Now consider an example in this particular service one. If the service 2 has got impacted and all the queries from coming out from client B in this particular example might get blocked, and it might exhaust the middleware in between also for any kind of a service. Now in this case, should a client A, C and D also be impacted? Because service 1, 3, 4 are still active. So bulkhead helps in these kind of scenarios where segregation of different components based on functionality and storage ensures that availability of a service, even if few or one of the services or part of that entire ecosystem would have gone down. Considerations which we need to take into consideration when we are evaluating this particular pattern. Partition boundary. Very important to understand the business and technical requirements before defining the boundaries. What should be isolated as an independent service or a component is of a very prime importance. Also, taking into consideration the technology and the level of isolation provided by the technology, considering namespace based segregation provided by Dockers and containerized solutions. Overheads in terms of cost, maintainability aspect should also be looked at. Does the solution actually need this kind of a overhead of bulkhead, or it needs a simple solution? Containers should be considered because uh, segregation of services can also be achieved through deploying the services over virtual machines as different processes. But in today's world, containers are the recommended way to go for segregation. Another important aspect is like, consider we want to give a higher level of reliability and resilience to a uh, important customers, and if we have that nature of the business or the services necessitates requirements around tenant based services, then the segregation can be on the tenants aspect also. While certain cases may need segregation even on geographical regions. Depends entirely on the problem context being solved. Next important is to understand when to use. When you are in need of an independent scaling of different services, this is a good fit. When you want to isolate components of varying risk or availability requirements, or when you are building a geographically distributed service to localize any failures and mitigate latency, as well as provide of availability based on regions. So consider that you have a downtime in US, but in India your users are able to um, access your services. When not to use, when budget is a constraint on idle resources, because when we are setting up different bulkhead components, there can be a heavier load on one particular set of segregated components, while another set of segregated components can have a lower amount of traffic. So budget can constrain this kind of a deployment pattern or bulkhead pattern. Bulkhead adds to the complexity of the system because you have to maintain a different segregated components and all. So if the nature of requirement, business requirement, doesn't fits in into this kind of a complex scenario, then this pattern is not a good fit. Just this particular diagram I'll iterate, where when we are looking at the edge devices, we don't generally we don't bring in this bulkhead segregation. When we are looking at firewalls and internal load balancers, to certain extent we can, depending on like if we are setting up it in different geographical regions, we do tend to have different firewalls for each region and different internal load balancers, which kind of like takes care of redirecting all the service requests between the internal services. So, and the third layer where the services components are there, definitely they are subject to segregations, and if the business requirement suffices, they are the best fit for this bulkhead component segregation. With that, I'll just jump to the filler evaluation. Reliability, definitely that gets enhanced because this particular pattern enhances the availability and the resilience of the overall system. Um, because this pattern brings in a degree of confidentiality, integrity, as well as availability, security pillar is also positively impacted. Performance, efficient management of demand and scalability enhances performance, uh, and cost optimization with extra set of deployments required. Cost definitely increases, and that's one of the trade-offs. Operational excellence, with the entire components having segregated, and logging and monitoring and metric generation is specific to each of the different segregated components, kind of like the overall load reduces on the operational excellence, and the operational excellence is enhanced, so it's positively impacted. With that, I'd like to end today's session. Hope to see you all soon on our next session, where I'll be covering another system design pattern. Hope to see you all soon there. Till then, bye bye.